Hey, thanks for coming back. Okay, part two, lesson 7. We're working on why Don messed up this inverse. Okay, so let's see if we are going to get the same thing Don did by finding the inverse of the equation y equals the root of x minus 3. So we know the process. We're going to switch x and y. Okay, y becomes x becomes y, and then we have to isolate y. So let's think about how we would do that. Well, we got to get rid of the square root first. So we're going to square both sides to do that. Okay, then we need to isolate y by adding 3 to both sides. Okay, so then we should end up with y equals, that's gone, x squared plus 3. Uh-oh. Well, if Don messed up, it seems like we did as well, right? Okay, well, let's think about this. Explain why Don's equation of the inverse is not complete. Okay, so they're not saying it's wrong necessarily, just not complete, and why the graph of the correct inverse is not a parabola. Okay, well, maybe we should graph this. Big hint, they gave us a grid here. So y equals square root of x minus 3. If you put that in your graphing calculator, square root function looks like this, and then moves 3 over. So we should have something that looks kind of like this, okay, for the original. Okay, now what we got to be the inverse is a parabola, right? Y equals x squared plus 3 with the vertex at 0, 3. So that should look like, oh, sorry, one sec. This one should actually be like this. Make that blue. There we go. That's our original. Y equals the square root of x minus 3. Okay, now our parabola, vertex at 0, 3, parabola opening up. Okay, now looking at that, you can see that the original didn't have that lower half of the parabola, and yet our inverse seems to have that. And there's not really much we can do about that. That's what shows up when we have y equals x squared plus 3 on the calculator. So what we have to do is we have to restrict the domain on our inverse to get rid of, which would, if we're missing the lower half of our original, that would correspond to this, the left side. And you can kind of look at this being our line of reflection and see how this is reflected to that, and this one would be reflected to that one. So we got to get rid of that. So to do that, we're restricting our domain to just being this part of the graph. So we're going to add on a little x has to be greater than or equal to 0. That's 0 there for x. And now that would be correct because it wouldn't be graphing this part of the graph and we'd only have the right side of the parabola. Okay, so when you're determining the inverse of a function, domain restrictions, if any, must be included in the equation of the inverse. This would not be right until we tack on that x greater than or equal to 0. So make sure that you graph the original and your inverse to confirm that one is actually a reflection over the line y equals x of the other one. Okay, let's look at the next page. Okay, we're almost finished. This is our last example. This is kind of a cool example. You'll wait and see what this comes out to be. It's very interesting. All right, so composition of functions comes back. F at f to the negative 1 of x. We're asked to find an f, the inverse of function of f of x. Boy, that sounds confusing. And original function was this, and I'm assuming that we already have calculated the inverse, and that would end up being let's see here, x plus 3 over 2. And you can check back to that example to confirm that, but that should be the inverse of this original f of x. Okay, so given that, we're now going to set this up. Now remember with composition of functions, you want to immediately change that to a different form and go f bracket f inverse and then bracket x and bracket and bracket. Okay, so we're going to replace the inside first. The inverse function gets put in there, and that's this. So it would be f at x plus 3 over 2. And now we're dealing with the original function, and we want to replace x with x plus 3. So let's go to the original function. Okay, 2x minus 3. So 2, I'm leaving room to replace x minus 3. Okay, so let's put our new x in there. X plus 3 over 2. And now we're going to simplify this. Okay, so when we multiply 2 times x plus 3 over 2, 2 is like 2 over 1. And these 2's would divide. 1's on top, 1's on the bottom. 2 divided by 2 is 1. So then we're down to just x plus 3. And then we still have our minus 3. X plus 3 minus 3 is going to be just now x. Interesting. Okay, let's try this one. We're trying this one, writing it in a different way. F inverse of f of x. Okay, once again, we're going to replace the inside function, and in this case it will be 2x minus 3, the original. 2x minus 3. Sorry about that. Okay, and now we are going to use the inverse function, this one here, and we're going to scoop out x here, and we're going to put in 2x minus 3. So scooping out x, we still have the plus 3 and divided by 2, and we're replacing x with 2x minus 3. All right, let's simplify this. 2x minus 3 plus 3, okay, we don't really need the brackets there, right? And we're going to notice minus 3 plus 3, that's going to equal 0. Now we're down to 2x divided by 2. Guess what? That's equal to x. Coincidence? I think not. Okay. The moral of the story here is that if you take the inverse and put it into the original function for x, if they are truly inverses of each other, you will get x every time you do that. Okay, so they summarize that down here. Two functions, f and g, are inverses of each other if f at g of x equals x or g of f of x equals x. That's a lot of x's to say. Anyways, that ends our lesson 7 videos, last lesson in the unit. Everybody study really hard for the test. But before you hit pause or hit end, I've got a joke for you. So the teacher said to the student, if you had $1 and asked your dad for $1, how much money would you have? The student says, $1. The teacher says, you don't know your math. And the student says, you don't know my dad. Okay. Anyways, all right, everyone. We'll look to the next unit for our next video lesson. And thank you for watching this one.